Now, before we solve another rational equation, let's look at three new terms that, that can be used to describe an equation. So, let's look at these. An equation that is true for all real numbers, for which both sides are defined, is called a what? Well, one of these. If it's true all the time, it doesn't matter which real numbers you're plugging in. Inconsistent doesn't sound right. Conditional doesn't sound right. It's an identity. Okay, and it says to give an example. Well, what would be an equation that is true for all values of x? Well, I can think of a really easy one. X equals x. No matter what value you plug in for x, say x equals 2. Well, there's x is here, so it'd be a 2 here and a 2 here. It's true for 2, and then you'll see that it's true for absolutely any number. Or I could have done something like x minus 2 equals x minus 2, or even something that's not quite as obvious. I could have done negative 2 times x minus 1 is equal to negative 2x plus 2. You'll notice that if you distribute on the left-hand side, you get negative 2x plus 2. So no matter what value you plug in for x, you get a true statement. All three of these equations are identities. Now, how about an equation that is true for no real number? It's never, ever true. Well, that's the one that's called inconsistent. And can you think of an equation that is never true? Well, how about x equals x plus 1? Do you think there's any number you could replace x with and give you a true statement? Of course not. No number is equal to one more than itself. As a matter of fact, you could subtract x from both sides and you would end up with 0 equals 1. Which is clearly false. And actually, this is an inconsistent equation as well. It's false. It's always false. Number 3. Well, which one's missing? Conditional. Conditional, an equation that's true for at least one number, but not for all real numbers, is a conditional equation. So at least one means it's not going to be inconsistent where there's no solution, but it's not going to be true for all values of x because that would be called an identity. So with these three terms, every equation we look at is going to be one of those types of equations: identity, inconsistent, or conditional. Okay, so let's solve one more rational equation. and then choose which of these it is: identity, conditional, or inconsistent equation. Well, I've got it all written out. Well, what do you think the least common denominator is? Well, we have an x minus 2 here, so that has to be part of the least common denominator. We have x plus 5 here. That has to be part of it as well. Well, lucky for us, this other fraction is simply the product of both of those. And it turns out that this would be the least common denominator. It would be x plus 5, x minus 2. We'll make it a fraction there. So notice when we get to this term, the one on the right-hand side, the entire denominator is going to cancel out. With the first one, only the x minus 2 is going to cancel out, leaving us with an x plus 5 on top. And in this fraction, the x plus 5 will cancel, leaving us with an x minus 2 on top. So let's see what we get. If the x minus 2 goes away because we're canceling it with this, we're left with a 4 on top and an x plus 5 on top. All right, then the second term. In this one, the x plus 5 is going to cancel with this x plus 5, leaving us with an x minus 2 on top and that 3 on top as well. And as mentioned earlier, the right-hand side is really simple. Now let me make this look a little more like a 2. The entire denominator cancels out with this, and it leaves us with just a 7. All right, so let's distribute on the left. 4x plus 4 times 5 is 20, plus 3x minus 6. 3 times negative 2 is negative 6, equals 7. So if we combine those like terms there, we get a 7x on the left. And if we combine I'll put a bar over them, the 20 and the negative 6, 20 minus 6 is 14, equals 7. Subtract 14 from both sides, giving us 7x equals, that'd be a negative 7. Divide both sides by 7, and we get x equals negative 1. Now, we have to plug this in to verify it, which I'll let you do. But assuming our arithmetic is correct, which I believe it is, this is the solution because we don't have to reject this as a solution. What numbers would we have had to reject as a solution in this equation? Well, in this equation, if you set x minus 2 equal to 0, that would mean x equals 2. So if x is a 2, that would give you a 0 in the denominator. So we know that x can't equal 2. And in this one, x can't be a negative 5, giving you a 0 in the denominator. So x can't be negative 5 either. And on this, we have the same restrictions. X can't be a negative 5 because it would make the entire denominator 0. X can't be a 2, it would make the entire denominator 0. So these were our restrictions, which we didn't have to use because our solution was not one of those numbers. And finally, is this an identity, a conditional equation, or an inconsistent equation? Well, it's not an identity because it's not true for all values of x. It's not inconsistent because it is true for at least one value of x. It's conditional. It's true. This is an equation when x is equal to negative 1. All other values of x will make this false. X equals negative 1 is the single solution to this rational equation.